Friends, welcome to you e-learning classes managed by Modern English School, Nevada. Dear students, myself Sujay Kumar, your mathematics teacher. Here I discuss the examples of Pythagoras theorem of exercise 7D. The all examples related to Pythagoras theorem. So see here how we can solve the examples of this part. Here is, I write example first. Here is sides of some triangles are given below. Determine which of them are right angle. Which of them are right angle triangle. So according to the Pythagoras theorem, it is clear the square of hypotenuse is equal to the sum of the square of other two sides. But hypotenuse is the longest side. So it is clear the longest side is the hypotenuse and remaining two is perpendicular or base. So first questions given 8 cm, 15 cm and 17 cm. Then it is clear 17 is the hypotenuse. First question 17 is the hypotenuse 17 cm because it is the longest and other is perpendicular and base anyone no problem. 8 cm and base is 15 cm. If we write base is 8 cm and perpendicular is 15 cm no problem, but hypotenuse is compulsory 17 cm because hypotenuse is the longest sides of the triangle. Now according to Pythagoras theorem, h square is equal to p square plus b square. Then what is h square? 17 square is equal to 8 square plus 15 square. Here is 289. 17 are 289. It is 64. 8 is 225. When you have to get here 289 and when you get it is also 289, then it is clear. So it is h square is equal to p square plus b square. Then it is right angle triangle. So it is right angle triangle. So it is right angle triangle. If it is not equal, then it is not a right angle triangle. Now find second questions. And second question you have 9, 11 and 6. So second question, what is hypotenuse? What is the longest? That is 11. So hypotenuse is 11 cm. Perpendicular, other is perpendicular 9 cm and base is 6 cm. You find h square is equal to p square plus b square, yes or not. So it is 11 square is equal to 9 square plus 6 square. It is 121. It is 81, it is 36. It is 121, 170. Then 121 is not equal to 170. It is clear. This side is 121, another side is 170. It is not equal, so you can write it is not equal, so it is not right angle triangle. You can say this is the not the sides of the right angle triangle. If your question is given in the algebraic form, like this is 2a minus 1, 2 root 2a and 2a plus 1. Here is problem. Here is given variable terms a, b, c, x, y, z, etc. And we cannot say who is greater or not. So this type of question, hypotenuse is always last part is called always hypotenuse. When your numerical form not given in algebraic form, then the last term is the hypotenuse. So f is 2a plus 1, b is 2a minus 1 and p is 2 root 2a. Now write h square is equal to p square plus b square. What is h square? That is 2a plus 1 whole square. What is p? 2 root 2 square plus b 2a minus 4 whole square. P or B no problem. You also write b and this b, but hypotenuse is compulsory b. Hence it is 2a whole square 1 whole square plus 2 into 2a into 1, because a square plus b square plus 2a. Here is 2 to the 4 to the 8a plus 2a whole square plus 1 whole square minus 2 into 2a into 1. Here is a square plus b square minus 2a. What you get here, you get 4a square plus 1 plus 4a. Here you get 8a plus 4a square plus 1 minus 4. But minus 4a plus 4a, you get 4a square plus 1 plus 4a. Now you find both are equal. Here is plus 8a, here is minus 4a, the result is 4a. So LHS is equal to RHS, hence we can say if h square is equal to p square plus b square, then it is clear the sides of this part is a right angle triangle. Hence you can say it is right angle triangle. Second example, a man goes 15 meter due to west and then 8 meter due to north. How far is he from the starting point? Suppose man is here and first it goes to west. Suppose west is there. How many? 15 meter. And then go to the north. Suppose B and then north C. And what is the distance to the starting point? And here is 8 meter to the north. Then it is clear what you have to find. This type questions anyway go to north, then move to south, east, west, anything. Then all times you only find the hypotenuse, then you can find the result of the solution. Here is 15 meter due to west, then 8 meter due to north. Then your question is what is the distance from a starting point now? So now the distance from a starting point is the hypotenuse. So only find AC is equal to AB square plus BC square under root by Pythagoras theorem. So here is AB, it is 15 square plus 8 square, and here is 225 plus 64, that is 289, and it is 17 meter. So you can say that now the man is 17 meter away from the starting point. Present time man is here, and before this man is there. Starting point is there, then goes west 15 meter, then now last goes 8 meter towards the north. Then what is the distance between a starting point and the last point? That is the hypotenuse, and that is 17 meter. Now see examples 4. That is a ladder is 15 meter long, reaches a window. A ladder 15 meter long, that means length of the ladder is 15 meter. Reaches a window which is 9 meter above the ground. Means here is the ground, from this point window is 9 meter above. Suppose it is window and it is 9 meter above the ground, and the ladder is reaches it. It is a ladder and it is reaches at 9 meter above the ground, and the ladder is 15 meter. Keeping its foot at the same point, the foot of ladder keeping at the same point at E, and turn into other sides. Turn into other sides. Here is ladder. Turn into other sides. And other sides of the street to reach a window 12 meter high. This is 12 meter. Then your question is find the width of the street. The one side is the house, other side the house. The ladder at the point from E, one side the window 9 meter above, another side window 12 meter above, but the length of the ladder is constant and that is 15 meter. And your question, what is the width of the steel? So it is clear, ladder is work as a hypotenuse and window height work as a perpendicular, and you have to find the base in both triangle. So first you find DE. So you find DE, and DE is equal to CE square minus CD square under root. It is the hypotenuse, it is the base, so base is equal to H square minus P square. So now write, it is C, it is 15 square minus 9 square, that is 225 minus 81, that is 144, and it is 12 meter. So DE is equal to 12 meter. Find out. What is BE? You write BE is equal to under root AE square minus AB square. So it is equal to 15 square minus 12 square. Then write 225 minus 144, that is 81, and it is equal to 9 meter. So what is the total width? Total width of a street is equal to what? It is 12 meter and it is 9 meter. Then total width is 12 plus 9, that is 21 meter. It is the total width of the street if the length of the ladder is constant. One times ladder is this side, other times same ladder is other side, but the height of window are different. So you find 2 times base and add it, then you can get the total width of the street. Example 5, that is 2 poles of height 6 meter and 11 meter, 6 meter and 11 meter, stands vertically, that is means both poles makes 90 degree with the ground, that is vertical, on a plain ground. If the distance between their feet is here, distance between their feet is 12 meters, then your question is find the distance between their toes. Find the distance between their toes. That means you have to question find the distance of AB if BC given 12 meters. So dear student, first you draw parallel line, that is ABCD. Draw parallel. This is D parallel to C. So if it is 90, then it is clear 90. If you draw parallel, then it is a form a rectangle, because here is 90, here is 90, and this line are parallel. So it is a rectangle. So it is 12 meters, then it is also 12 meters. It is 6 meters, so it is also 6 meters. Here is 11 meter, it is 6 meters, then what will remain? That is 5 meters. So first you find that solution. You write, draw DE parallel to CB. So DCBE is a rectangle. Hence DE is equal to CB. Hence DE is equal to 12. What is A? AE is equal to AB minus EB. That is AB is 11 meter and EB is 6 meter, because EB equal to DC. So it is 5 meter. So now in triangle DEC, your question find AD. Sorry, now in triangle DEA. So your triangle AD is the hypotenuse. So AD is equal to under root DE square plus AE square. Then it is equal to 12 square plus 5 square. Then it is 144 plus 25, that is 169, and it is equal to 13 meters. So you can say this AD is equal to 13 meters, and it is your solution. Question number 6. In a rhombus of side 10 cm, one of its diagonal 12 cm long, find the length of second diagonal. First, what is rhombus? Rhombus is a parallelogram in which all sides have equal length, and other property of rhombus is its diagonals are bisect to each other at right angle. There are two properties in the rhombus. First, it is parallelogram and all sides have equal length. Second property, its diagonals bisect to each other at right angle. So first we draw a rhombus ABCD. All side has 10 cm, then also 10 cm, 10 cm and 10 cm. Suppose one diagonal is given and that is 12 cm. Given BD is 12 cm. You have to find what is AC. Both diagonal intersect at O. So this angle is right angle. It is also right angle. It is also right angle, and all are right angle. And it is bisect to each other. If BD is 12, then it is clear it is 6 and 6, then total 12. So it is 6 cm. It is O. You have to find AO. So you write AB solution. AB equal to 10 cm, already given. BD is equal to 12 cm. So BD is equal to 12 cm. So BO is equal to 12 by 2, that is 6 cm. And angle AOB 90 degree. Then AB is the hypotenuse. Opposite of right angle, it is hypotenuse. So AB square is equal to AO square plus BO square. Then it is 10 square is equal to AO square plus 6 square is equal to 100 AO square plus 36. Here is 100 minus 36 is equal to AO square. 64 is equal to AO square. Then AO is equal to under root 64. What is it? 8 cm. So what is AC? AC 2 times of AO. So 2 into 8 cm, that is 16 cm. It is the second diagonals of the rhombus. So in a rhombus, first all sides have equal length and diagonals are perpendicular bisect to each other. If one diagonal given, then we can find the other diagonal with the help of the pythagorous. Thank you, dear. Example 7. ABD. ABD is a right triangle in which A is 90. Triangle not ABC, triangle is ABD is right angle at A and AC perpendicular to BD. This AC perpendicular to BD. Then prove that AB square is equal to BC into BD, AC square is equal to BC into CD, and AD square is equal to BD into CD. So dear student, first to find one by one. First is AB square is equal to BC into BD. All questions related to the similar, and there are 3 triangles in it. two small triangle and one large triangle. And each questions are on the basis on the relation of the similarity of two triangles. But problem is that how can find the similar of two triangles? ABC similar to DAB or ABC similar to DAB, otherwise DAC similar to DCA. All are similar, but according to question, first to find which triangle are similar. Here is given AB square, AB two times, my love, AB two times, and BC into DD, then it is clear. AB two times means one times in a small triangle, another times in large triangle. AB in ABC and also in ABD. Yes, and BC BC in a small triangle, BD in large triangle. So first question, it is clear that triangle in triangle ABD, in triangle ABD and triangle CBA. So angle A in large triangle is equal to angle C in a small triangle is 90. This angle A is 90 in big triangle and this angle C 90 in a small triangle. And angle B is equal to B. Both are common. This B also in triangle ABC and this B also in DBA. So triangle ABD similar triangle CBA by property A. If triangle are similar, then according to angle, you can find their corresponding sides. So here is A in a large triangle, so that is BD. Here is C in a small triangle, that is AB. B in large triangle, AD. A small triangle, AC. What is remain? BD, AD in large triangle, so AB remain. Similarly, in a small triangle, ABAC, and what is remain? That is BC. Here you get AB square, find out first and last. So you write BD by AB is equal to AB by BC and cross multiplication, then you get AB square is equal to BD into BC. So it is the first solution of your question. So first you take similar relation between these. Similarly, next question, and that question is AC square is equal to BC into CD. Find out AC square means taken two times and BC into CD. It is clear both are small triangle because AC present in this small triangle and also in this small triangle, and BC in first triangle and this in second triangle. So it is clear for proof of this solution, it is only possible when you take the similar relation between these two small triangles. And similar relation between here is like as 1, 2, 3. So first you write solution, angle 1 plus angle 2 is equal to 90. You have to do this. And angle 2 plus 3, 90. This 90 is region DAB is 90. And this 90 is region ASC, angle sum property. So you can say 1 plus 2 is equal to 2 plus 3. 2 can say that is 1 is equal to 3. As it is. Now write in triangle BCA and triangle BCA and triangle ACD. This is BCA and ACD. This triangle and this triangle. What is the relation? BCA 3 and here is 1. Next, here is C and C also 90. It is provable. So what you conclude? What you conclude here? Both are similar. Triangle BCA, similar triangle ACB by A property. Now find the relation between their sides. Angle 3 is equal to angle 1. Opposite of 3 is what? AC. And opposite of 1 is DC. Opposite of C is AB. And opposite of C is AD. What is remain? You write AC, AB. You write AC, AB. That's clear. Here is remain BC. Here you write DC and AD. DC and AD. Clearly remain AC. You have question is AC square. So you take first and last. Then AC by DC is equal to DC by AC. Cross multiplication. Then AC square is equal to DC into DC. Okay. So this question is AC square, that means AC 2 times. Then it is clear you take these two triangles of the similarity relation between them. And last is question, that is AD square is equal to BD into CD. Here is AD square, BD, CD. AD 2 times, one is a small, one is large. DC, BD means one is a small, other is large. So it take triangle in triangle ADB, in triangle ADB, large triangle, and triangle CDA. Angle A in large triangle 90, and angle C in a small triangle it is 90 degree both. Next, angle D in large triangle and also angle D in a small triangle, it is common. So triangle ADB similar triangle CDA. Triangle ADB similar to triangle CDA by property A. If these are similar, then take their sides of the corresponding. A is equal to C. What is A? Here. Opposite is BD. C. Opposite is AD. Next. Angle D, large triangle. AB. A small triangle. AC. What is remaining large? BD, AB. BD, AB. Then remaining AD. In a small triangle, AD, AC. AD, AC. Remaining DC. You have to prove AD square. So you take first and last. So BD by AD is equal to AD by DC. Cross multiplication. Then you write AD square is equal to BD into DC. So this is your last solution of this.